Hi everyone. So today we will solve LeetCode 263. It's called the ugly number. So in this question we will be given an integer n and we need to return true if it's an ugly number, otherwise false. And coming to its definition, so ugly number is nothing but a positive integer which does not have a prime factor other than 2, 3 or 5. So if our number has any prime factor which is apart from these three, then we would return false. But if all the factors are among these three only, then we will return true. Like suppose I've also shown you the example, like n here is 6. So if we factorize it, we would get 2 into 3. Now 2 is also acceptable, like you can see here, and 3 is also acceptable. And we have no other factor which is apart from 2, 3 or 5. So that's why 6 becomes our ugly number. So we return true. Coming to the second example, n is 14. So if we do prime factorization of it, we would get 2 into 7. Now 2 is acceptable, but 7 is not, because we cannot have anything apart from 2, 3 or 5. So that's why it's not acceptable. So we would return false, since 14 is not an ugly number. So I hope the question is clear. So let's head over to the approach. Coming to the approach of solving it, see, we are given at the start only that ugly number is always a positive integer. So we can at the first only put a check that if our number is not positive, that is, it is less than equal to 0, we can directly return false from here, because we know ugly number is always a positive integer. So this early check we would put in the starting of our code. Then now let's deal with the positive cases. Now let's look at this example. Suppose our n is 36. So if we would prime factorize it, we would get 2 18s, 36, 2 9, 3 3s, and 3 1s. So you would get something like 2 into 2 into 3 into 3. This is acceptable because 2 is acceptable. This is also 2, so acceptable. 3 is also acceptable, and 3 is also acceptable. So these all are fine and are among these three only. So that's why 36 is indeed an ugly number and we return true. So as you can see, we would just simulate this process only what I did here. So whatever number we will have, we would first check if it's divisible by 2. Like here we checked, right? 36 was divisible by 2. That's why we divided it by 2 and find out the quotient. So that I would do here also. So if it's divisible by 2, we would, if it's divisible by 2, then we would divide it by 2. Simple. Because, and if it's divisible by 3, we would divide it by 3. And if it's divisible by 5, we would divide it by 5. And suppose a case arises when it's not divisible by any of them. Like suppose n is suppose something like 11. So it's not even divisible by 2, nor 3, nor 5. So it's not divisible by any of them. So if such a case arises, we would return false, because any of all of these were not able to, any of these in fact were not able to divide the n. So that's why we return false directly. So, and also if it was dividing, suppose we had 36. So we check if is it divisible by 2? Yeah, it is. So we divide by 2 and we get 18. Then for 18 we check is it divisible by 2? Yes, it is. So we divide it by 2 and get 9. For 9, we check it's divisible by 2. It's not. So we check for 3 whether it's divisible by 3. Yes, it is. So we divide by 3 and we get 3. Again, for 3 also, we divide by 2 and check whether it's divisible or not. So it's not divisible by 2, so we don't take it. Then we check for 3 and we see that yes, it is divisible by 3. That is, our n is divisible by 3. So we divide it by 3 and we get 3 by 3, that is 1. And as soon as we got 1, we would stop here. So if we finally repeated our process and eventually got 1 at the end, that means our number was ugly because we are at each step we had either 2, 3 or 5, any of them we had to divide our number. Had it been the opposite case, like if any of them were not able to divide our n, then as told here, we would directly return false. So let me show you on another example as well. Suppose we have n equal to, let's say, 21, so 42. So suppose we have something like this, 42. So as I told you, what you would do, you would first check whether it's divisible by 2. Yes, it is. So we divide it. So we get 21. Now again, we check it's divisible by 2. It's not. So we check by 3. So yeah, it is divisible by 3. So we divide by 3 and we get 21 by 3, which is 7. So now for 7, we check is it divisible by 2? It's not. Then we check for 3. It's not divisible by 3 either. And neither it is divisible by 5 also. So it's not divisible by any of them. So that's why we return false here, because we were not able to get 1 at the end. Had our number be an ugly number, like suppose um we had something like 16. So had it been an ugly number, we would obviously get a 1 at the end. Here, like you can see, every time we divide by 2, and we would finally get 1 at the end. So if we get 1 at the end, that means it is indeed an ugly number. But at any place, we got stuck because none of our factors can divide it, then we return false. So yeah, this was the approach. Let me code it up so you can get more clarity about this. So I've written the code of it. So we need to return a Boolean result that is true or false, and we take n as an input. So the first check I talked about, if our number is negative or 0, then we directly return false because ugly number is always a positive integer as given in the question. And for positive integers, we do something like this. We use a while loop and we keep reducing our number until we reach 1. As soon as we reach 1, as we discussed, we would stop. So in this process of reducing our number, we every time check if our number is divisible by 2. I've already told you about this. This is used to give a remainder. So this statement is nothing, but it means if a number on dividing by 2 gives a remainder equal to 0, that means it was completely divisible by 2. So that then we divide our number by 2. Similarly, else if our number is it was divisible by 3, we divide it by 3, and similarly for the 5. If it's divisible by 5, we divide it by 5. And if it's not divisible by any of them, then we go to the else case, and thus we return false here because none of them were able to divide our number completely. So which means we had some other factor apart from 2, 3 or 5. So that's why we return false. And finally, if our loop ends, means this condition got violated and greater than equal and greater than 1 got violated means and reached 1. So what you would do if n reached 1? So you would return true here. So that's at the end we return true, saying that it's yes, it was an ugly number indeed. So yeah, this was the entire approach. Coming to the time and space complexity. See, space complexity is simple. We aren't using any additional variable. So space complexity is constant. Coming to the time complexity, this is important. So suppose we had something like, you can say 16, and I would take one more example. Let's take 125. So suppose we reduce this, we divided by 2, we got 8. Then by 2, we got 4. Then by 2, we got 2. And then by 2, we got 1. And similarly, this we divided by 5 because 2 and 3 won't be able to divide it, right? So here we would get 25, then again 5, then again divide by 5 and get 1. So number of steps in this is nothing but you can see right here, this is first step, this is second, this is third. So every time we are dividing by 5. So number of steps is nothing but log of n to the base 5. Similarly here, every time we are dividing by 2. So number of steps is nothing but log of n to the base 2. You can cross check also. Log of n is here 125. So log 125 base 5 is nothing but 3. And indeed, we perform 3 steps only. And similarly here also you can check. N here is 16. So log 16 base 2 is nothing but 4. And indeed, yes, we have performed 4 steps here also. So the thing I'm trying to tell is, so like that you can see we can have either log log n to the base 5 steps, or log n to the base 3 steps, or log n to the base 2 steps, right? This would depend on whether we are dividing it by 5 or 3 or 2, or a combination of them as well. So we know when we talk about time complexity, we always talk about worst case scenario. So worst means the largest value, and largest among them is nothing but this thing. So log n2 is our largest value. It's greater than this and this. So that's why this becomes a time complexity. So this is the time and space complexity of our solution. So I hope the question is clear. So yeah, this was it for today's video. I hope you like this approach and the code as well. So yeah, uh, I would be making such more videos shortly. So yeah, if you like the video, please like the video, and drop your comments and also hit the subscribe button. Thank you so much for watching.